want to follow along in your book, you can. We're on page 11. And again, as I mentioned yesterday, we have a lot of what are called definitions, postulates, theorems that we are going to be using. A postulate is something that is assumed to be true, whereas a theorem is something that is proven to be true. All right, a postulate is something that is assumed to be true, and a theorem is something that is proven to be true. And that's the difference between a postulate and a theorem. And remember, I told you yesterday that we don't want to memorize theorems and postulates by their number. If it doesn't have a name, we just want to memorize the theorem because numbers always change. So when I look at your proofs, when I look at your work, if you say postulate 1-1, I won't know what you're talking about because I haven't memorized them by a number. I know them by the postulate name or the postulate itself. So keep that in mind when you are memorizing and doing these things, that we are memorizing it by the postulate or the name. All right, so everything has to start somewhere. Everything is not necessarily proven. It has to start someplace. So we have what are called undefined terms. Terms that do not necessarily have a definition. It has a description, and they're undefined, and they're assumed to be true. They're assumed that they're basically our building blocks, what we build all our definitions and theorems upon. All right? So the first one, undefined term, is a point. A point. A point is a location. That's all it is, it's a location. A point has no dimensions, has no thickness, has no length, has no depth. It's basically an individual entity. Alright? Like if I say over there, alright, I'm pointing to a point, a place over there, and it's just a point. It's just a location where I'm pointing to. First undefined term, location, no dimensions. No dimensions. Make sure I'm on here. There we go. So every undefined term we use to define another term, where the next term is a line. A line. A line is a set of infinite points extending in opposite directions. So again, we had a point, location. Now if we take a bunch of points, an infinite set of points, put them together, going in opposite direction, one going that way, one going that way, keeps on going, never stops, we have a line. Has one dimension. Has length. Does not have any depth. Does not have any width. Just has length. Our old printers that we used to have, dot matrix printers, used to spell out all your words when it's printed by using dots, putting dots together. Our TVs, we get that image because we have a bunch of dots put together to create that image of different colors. So all our diagrams, all our figures that we will be drawing in geometry are made up of dots. but we use a pencil and draw the line. That's just a bunch of infinite number of dots, many dots. And we just may have a few of them that are noted on our line. So there's our line, A, B, C, D, and E, that has those points, but again, there's many points in between. How do we name a line? We name a line with 2 points. With a line on top with 2 arrows going in opposite direction. So we say this is line AB. Or we can say line BC is the same line. We could say AE, that's the same line. All these points are on the same line. We can use any 2 points to name a line. I don't need more than 2 points to name a line. And we'll see that in a postulate that will come up. All I need is 2 points. So everybody can name this line differently and still be correct. We could have AB, line AB, we could have line AC, we could have line AD, we could have line AE. Or line BC, line BD, line BE. Or we can have line CD, line CE, or line DE. You know, all those different names would be the name for the same line. Alright, but we need 2 points to name a line. 1 dimension. Dimension is length. A point, no dimensions. No dimensions for a point. No length, no width, no depth. A line, 1 dimension. Set of infinite points extending in opposite directions. Extending in opposite directions. And again, doesn't end. Keeps on going. Keeps on going, keeps on going, keeps on going, keeps on going. Even though on the board it looks like it stops, but these arrows show that they keep on going. Arrows show continuous or continuity. It's going. So we got the point, we get the line. We have a plane. Instead of infinite point, making a flat surface that extends infinitely. Making a flat surface that extends infinitely. 2 dimensions. Has length and has width, no depth. A sheet of paper. So we talk about is a plane. So this sheet of paper is made up of a bunch of points, all connected together. Alright? Although this sheet of paper will extend infinitely in the directions, length and width. So this plane would actually get bigger and bigger and bigger. Alright, how do we draw a plane? If we want to draw a plane, we use parallel lines. And usually we use at an angle. And there's our plane. We have points. I forgot, we could also name this line that we don't usually, but we could say, let's do line M, a lowercase cursive letter. Do not use that too often, but a lot of times you will see that in diagrams and books and things, a lowercase letter. Here's our plane. We label or we name the plane, draw a little parallelogram, and pick 3 letters. Plane ACD. Plane ACD. Now we can pick any 3 letters and name that plane as long as they are not on the same line. And we'll learn what those are. They're to be non-collinear points. But we wouldn't use AEC, although in this one we could. But if we're just letters by itself, we want to try to use points that are not on the same line, because if this was my line here, there's many different planes that could go through those 3 points. So we always want to use 2 points here and a point here. There's only one plane that can go through those 3 points. So we always want to try to use non-collinear points. So we use the parallelogram, 3 letters, or we could use the capital letter plane P. The difference is these have points by it, so we know these are points. This does not have a point, so therefore we know that's the name of the plane. Plane P. And the last one, space. That is basically the set of all points. 3 dimensions. It has length, has width, and it has depth. It has length, it has width, and it has depth. In those 3 dimensions. Those are our undefined terms. There's no definitions, they are basically descriptions of what we have that we would use in geometry. Alright, so we need to know what the definition or the descriptions are. We need to know what kind of dimensions they have. No dimension, 1 dimension, 2 dimensions, and 3 dimensions. We need to know how to label them. Make sure you know how to label them. And make sure you know how to label a plane and how to draw a plane. Okay? Any questions on that? Okay, let's look at some defined terms. Collinear points. Collinear points. Actually, it means exactly what it says. Collinear means what? Same line. So when we look at this diagram here, give me some collinear points.
C and E.
Say that again.
C and E.
C and E. Alright, so when you are naming these, make sure you are naming me what you are giving me. Alright, even though she put the word and in between, it's better to say point C and point E. That way we don't get confused, oh, she just gave me a line if she says CE. But she did do it correctly by putting the word and in between. But point E and point C, yes?
Point C and point D.
Point C and point D, yes? How about going in threes? Collinear points.
Point A, point B, and point C.
Point A, point B, and point C. Alright, what about point B and point D? Are they collinear? Are you sure? Are you positive?
Yes.
Alright? We're going to learn that 2 points are always collinear. Even though we may not see a diagram there, 2 points will always be collinear. And we'll see that postulate in just a few seconds, a few minutes. Okay? 2 points will always lie in the same line. Alright, collinear points. So therefore, what are non-collinear points?
Points that don't lie in the same.
Points that do not lie in the same line. Name me some non-collinear points. Connor?
Did you say all points are collinear?
No. We said 2 points
Oh.
are always collinear. 2 points will always lie in the same line. So give me some non-collinear points.
From there.
Mm-hmm.
Point A, point E, and point D.
Point A, point E, and point D, correct? Somebody else.
Point A, point B, and point D.
Point A, point B, and point E, yes. Right? So therefore, how many points do we have to have non-collinear points? 3 or more. Alright? In geometry, some of my favorite questions are sometimes, always, or never questions, where you have to think. Take for instance, I would say 2 points are blank collinear. Sometimes, always, or never. 2 points are blank collinear. Sometimes, always, or never. Always. 2 points are always collinear. 3 points are blank collinear. Sometimes, always, or never. Sometimes. Okay? So, again, those are some good questions to get you to think about collinear and non-collinear. Next one. Coplanar points. Coplanar points. Coplanar points would be what type of points? Anyone?
Points on the same plane.
Points in the same plane. One thing we'll have to practice on is drawing three-dimensional. Because drawing on the whiteboard is just two-dimensional, but we want to make it three-dimensional. there's my two planes. Two planes that intersect, cross each other. Alright, so give me some coplanar points. Coplanar points. I guess you guys are drawing this. Let me help you here. All right. First of all, to draw a coplanar, two planes that intersect, you're gonna draw two intersecting lines. Doesn't matter how you draw. And now you're gonna make parallel lines. So whichever way you do this line, everything else is drawn the same way. And then you, let's got that one. Then you connect the lines. And you try to make all the lines the same size, or your edges the same size. Makes it help. This one's a little bit longer, so it looks a little weird. But that's how you're going to draw your intersecting lines. All right, so here, some coplanar lines. I'm sorry, some coplanar points. Coplanar points. Give me some coplanar points. Points that are in the same plane.
A and B.
Say that again.
A and B.
All right, remember
Point
point A and point B. Correct. All right, same plane. Yes. Yes.
Point D and point F.
Point D and point F. Let's get away from 2 points. Let's get more points. They're on the same plane. Points that are on the same plane.
Points A, C, and E.
All right, make sure you put a point by each letter.
Point A, point C, and point E.
Point A, point C, and point E. Okay, yes? The others.
Point D, point B, and point F.
Point D, point B, and point F. Okay? Get away from 3 points. Let's get to 4 points. Coplanar points.
Point A, point B, point C, and point E.
Very good. Yes. Okay? Now we're going to determine that to determine a plane, give me a name of this plane here. Isaac.
Plane F.
No, because it has a point with it, so it's not named. So it's actually a point, so you don't want to name the plane after a point, you want to name it after
Plane FBD.
plane FBD, okay? Caleb? There's no M there, so just
No, I
what,
thought you were asking like,
no, give me another name for this plane.
plane CBD.
Plane CBD, okay? Aaron? FCD, okay, yes? I put another point here, put another point right here. Can we name this plane can we name this plane CGB? Can we name this plane here plane CGB?
No.
I hear some yes, I hear some no. But which one? If I say, all right, point to plane CBG, which plane am I talking about?
If we talk about both, right, because they're intersecting right now.
I could be talking about. So that is not a good way to name that plane, because you don't really know which one. You say, okay, it's this one. No, you're wrong, because I was really talking about this one. Or you may point to this one. No, you're wrong, because I was really talking about this one. All right. So what is the difference between the way we were naming the planes before and naming the plane with these 3 points? What is the difference?
Intersection.
What's that?
The intersection.
Yeah, but it's a bigger difference.
They're all different planes.
All right, the first one was on different planes. Well, yes and no.
Because, line CGB is the intersection of those two planes.
Right? So what about those, what can we say about those 3 points?
They're collinear.
They're collinear. Whereas before we said line, plane F, C, D, they were,
Coplanar.
what's that?
Coplanar.
They are coplanar because the plane will always, but you said C, point G, and point B were on the same line. They're collinear. What's point F, point C, and point D? What kind of points are those?
Non-collinear.
Non-collinear. So to name a plane, we want to make sure we use non-collinear points. We don't want to use the collinear points. To name a plane, we want to use non-collinear points. Non-collinear points to name a plane. So, I do not want to name a plane CGB. Okay? So there's a difference there. Questions so far? If we have non-coplanar points, that would mean non-coplanar points would mean what?
Don't have the same plane.
Do not lie in the same plane. Points that do not lie in the same plane. All right, segments. Part of a line with 2 endpoints, including the points between. All right, give me a name for this line.
Line A,
Okay, another one. Abby?
Line AC.
Okay, another one. Connor?
Line AD.
Okay, oh, the same line, correct? A segment is part of a line. So if we take a part of that line and stop it, we have a segment. To name a segment, we still use the 2 endpoints, but with a segment on top, no arrows. Segment AB, segment AC, are they the same? No. 2 different parts. Alright? So the endpoints are important. And the way you name it verbally is important. Because we just say AB, well, are you talking about a line? Are you talking about a segment? Are you talking about an array? What are you talking about? So that's why I'm always saying, we're naming points, use point before it. We're naming lines, use line before it. If we're naming segments, put segment before it. So segment AB, segment AC. Segment AB, segment AC. Array. Part of a line with one endpoint and all points after. Part of a line with one endpoint and all points after. Using the same line here. Ray AB or ray BA. Are they the same? Everybody agreed? No, they're not. Ray AB is go from here this direction. Ray BA is from B this direction. So they're different rays. So it's very important that we remember that when we draw the ray on top, that the endpoint is at the endpoint. Now, ray AB and ray AB are the same. They're written different, but if you notice, the endpoint is the A going to the B. The endpoint is the A going to the B. Yes?
So if you had ray BA and ray BC, would it be the same way?
Ray BA and ray BC?
Since they both start at B.
No, but they're going different directions. So they'll have different points with it. All right. Where am I at here? Geometry. Physics. I haven't changed the word physics, but that's the geometry homework there. Page 16, 9 through 35, odd. I'm going to change that a little bit and go do 9 through 25 odd. 9 through 25 odd. Page 16, 9 through 25 odd. Okay? Have a good day.